Good day, Philippines. Hello, Region 1. Aloha, San Carlinian learners. Airing live from the mango bamboo capital of the Philippines, San Carlos City. You're tuning in to CCN Broadcast Center, a virtual home of every SDO-SEC learner, where passion is the key. Learning paves the way. With our division mantra, developing creativity, maximizing versatility. This is your CCN Broadcast Center. CCN Broadcast Center, a virtual home of every SDO-SEC learner.
Good day, viewers. I hope you are all feeling well today. Another wonderful day for another lesson. So sit back, relax, and stay tuned. I'm Ma'am Rizzaly Siapno, your today's webcaster. Before we start our new lesson, let's have a short review on your previous lesson. If you haven't watched your previous lesson, you may watch it on our YouTube channel at SDO SCCP TV. So going back to our review, you are going to identify the words or word using the jumbled letters inside the parentheses. You may comment or type your answer on the comment box. For jumbled letters number 1, I'll give you 5 seconds to think of the answer. And the answer is conductors. Next number, 5 seconds to think of the answer. And the answer is insulators. For the third jumbled letters, the answer is plum pudding. The fourth jumbled letters, the answer is electron. The last number is the answer is proton. Very easy, right? I know you all got it right. And for that, I'll give you a virtual clap. For our new lesson in Science 8, Quarter 3, Module 3 is Atoms Inside Out. Specifically, Lesson 3, the number of subatomic particles in atoms, ions, and isotopes. For our most essential learning competency, determine the number of protons, electrons, neutrons in a particular atom. For our specific objectives are interpret shorthand notations for isotopes and atoms. Next, infer that ions are formed from the removal or addition of electrons. The last one is evaluate the net electric charge of an atom. Before we start our new lesson, let's have a short brain test. We have here a picture of nuclear model of an atom. You are going to label the proton, neutron, and electron. We are going to place our answer inside the box. You can type your answer on the comment box. I'll give you 5 seconds to think of the answer. Okay, time is up. For the first box, the answer is electron. The second box, the answer is proton. And the third box is neutron. Very easy, right? Next, you are going to match the 3 subatomic particles of an atom in column A to its charges in column B. For column A, we have proton, electron, and neutron. For column B, A, no charge or zero charge, B, positive charge, C, negative charge. I'll give you 5 seconds to think of the answer. Okay, let's answer. For number 1, the answer is positive charge. Next, electron. So going back, what are neutral atoms? A single atom is said to be electrically neutral if its number of electrons is equal to the number of protons. The atomic number of an element also specifies the number of electrons in neutral atom. So mathematically, for a neutral atom, Z is equals to P equals to E, where Z is the atomic number, P is proton, E is electron. Notice the atomic structure in figure 1. Symbol of helium atom on the left and its atomic structure on the right. Do they have equal number of protons and electrons? The answer is yes. Since the mass of an atom is concentrated in the nucleus, the mass number designated as A is equal to the sum of the masses of the protons and neutrons. That is, mass number is equals to protons added to the number of neutrons. For neutral atom, atomic number is equals to the number of protons equals to the number of electrons. The number of neutrons is equals to mass number, subtract it to number of protons. And figure 2 shows the symbol of the element where the mass number is written as superscript and the atomic number is written as subscript. So for example, how many protons, electrons, and neutrons are present in boron? For the solution, mass number is 11, atomic number is 5. So since atomic number is equals to protons equals to the number of electrons, so the protons and electrons is 5. So the number of neutrons is equals to A, subtract it to P. So the number of neutrons is 6. So next, what are ions? Atoms may gain charges. This happens when electrons are lost or gained by the atom. When this happens, the atom becomes an ion. A negative charge ion or an ion has more electrons than protons. A positive charge ion or cation has fewer number of electrons than protons. The net charge of an ion is the difference between the number of protons and the number of electrons. So therefore, the charge of ion is equals to the number of protons, subtract it to the number of electrons. For example, a neutral lithium atom has an atomic number of 3, has 3 protons and 3 electrons. If the atom loses 1 electron, it becomes an ion or cation with a charge of positive 1. We have here the net charges of lithium atom and lithium ion. For the number of protons, they are both positive 3. For the number of electrons in lithium atom, negative 3. For lithium ion is negative 2, which it loses 1 electron. For the net charge of lithium atom, 0. For lithium ion, it is positive 1. For the symbol, for lithium atom, capital L small I. For the lithium ion, capital L small I with a charge of ion of positive 1. In figure 4 shows the shorthand notation of lithium ion. The superscript at the right denotes the charge of the ion, wherein the number of electrons may be determined. The charge is 0 when there is no superscript shown. For example, determine the number of protons, electrons, and neutrons of fluorine ion. So the solution, the given are A, 19, Z is 9, and the charge of ion is negative 1, which means it gains 1 electron. The number of protons is 9, the number of electrons is 10, It is because there is -1 charge of ion. That means it gains 1 electron. The number of neutrons is equals to A, subtract it to P. The answer is 10. What are isotopes? Isotopes are the atoms having the same atomic number but with different mass number. Notice the table on isotopes of hydrogen. The element H1, H2, and H3. They are all different in mass number, and also they are different in neutrons. What makes the 3 isotopes of hydrogen different from each other? Different isotopes can exist, and this can be identified by its respective mass number. Mass number is the sum of the number of protons and the number of neutrons in the atom. For example, the H3. H3 has a mass number of 3. Referring to the table, its number of proton is 1 and 2 for neutrons, giving a total of 3. So mathematically, mass number of tritium is equals to P plus neutrons, which is N. So the mass number of tritium is 3. To summarize our lesson for today, differentiate atoms, ions, and isotopes. Atoms are the smallest particles of matter that retain the characteristics of an element. Ions are the atoms with an equal number of protons and electrons and are formed when an atom loses or gains electron. Isotopes are atoms of the same element with an equal number of neutrons in the nucleus. Now, let's answer our activity, Find Me. So for question number 1, what is the element with an atomic number of 15? The answer is phosphorus. Next, how many protons does the atom of this element have? The answer is 15 protons. Next, how many electrons are there in an atom of aluminum? The answer is 13 electrons. And for the last question, among the elements in the periodic table, which has the smallest number of proton? The answer is hydrogen. We are done in our lesson. Now, let's test your understanding. You choose the letter of the correct answer, or you can type your answer on the comment box. So for question number 1, one isotope of oxygen has the atomic number of 8, and the mass number is 18. An atom of this isotope contains blank. A, 8 protons. B, 8 neutrons. C, 9 neutrons. Or D, 18 electrons. 5 seconds to think of the answer. And the answer is 8 protons. Next question. Element A has a mass number of 100, while element B has an atomic number of 118. What will be the number of electrons of element B? A, 59, B, 60, C, 118, or D, 120? The answer is 118. Question number 3. Which of the following subatomic particles determine the identity of an atom? A, protons. B, neutrons. C, protons plus neutrons. Or D, electrons plus protons. The answer is protons. Question number 4. Which of the following statements correctly describes atoms, ions, and isotopes? 1. Neutral atoms has equal number of protons, neutrons, and electrons. 2. Atoms are the smallest particles of matter that retain the characteristics of an element. 3. Isotopes are atoms of the same element with an equal number of neutrons in the nucleus. 4th, ions are atoms with an equal number of protons and electrons and are formed when an atom loses or gains electrons. So for letter A, 1, 2, and 3. Letter B, 2, 3, and 4. Letter C, 1, 3, and 4. Or letter D, 1, 2, 3, and 4. The answer is B, 2, 3, and 4. And for the last question, how many protons, neutrons, and electrons are there in the neutral atom of chlorine? Letter A, 17 protons, 15 neutrons, and 17 electrons. B, 17 protons, 17 neutrons, and 17 electrons. C, 17 protons, 17 neutrons, and 18 electrons. Or D, 17 protons, 18 neutrons, and 17 electrons. The answer is D, 17 protons, 18 neutrons, and 17 electrons. For your assignment, you are going to complete the table below and you will write your answer on a separate sheet of paper. You may refer on your self-learning module, Quarter 3, Module 3 on page 18. We are done on our lesson. It was indeed a joyful learning. Again, I'm Ma'am Rizzaly Siapno, signing off. Thank you for watching.
Good day, Philippines. Hello, Region 1. Aloha, San Carlinian learners. Airing live from the mango bamboo capital of the Philippines, San Carlos City. You're tuning into CCN Broadcast Center, a virtual home of every SDO-SEC learner, where passion is the key. Learning paves the way. With our division mantra, developing creativity, maximizing versatility. This is your CCN Broadcast Center. CCN Broadcast Center, a virtual home of every SDO-SEC learner.